Hey College Algebra. In today's video, we're going to start leaning away from quadratics and more talk about polynomials. So in this lesson, you guys will learn how to find the zeros of a polynomial and how their multiplicity of the zeros and the degree of the polynomial affects the graph. And so here in this example, we're essentially looking at the same polynomial, except our leading coefficient here is positive and our leading coefficient here is negative. And we'll be looking at examples like that here in a second. But anyways, before we get started, we're going to talk about what the definition of a polynomial is, or what does a polynomial look like. And so we can generalize the way polynomials look in this case right here. And so all a polynomial is a function as represented by many terms, and these a's right here represent constants multiplied by our x. Now, here in a second, we're going to be talking about degrees of a polynomial. And what a degree is, it is the largest exponent of your function. So here, n is going to be our degree because it is the largest exponent. Okay, things that polynomial can't be, or it has to be a non-negative integer, and it can't be a fraction. So let's look at some examples and determine whether or not they're polynomials or not. Here, all of our exponents are, this could be 1, are either, they're positive integers, right? So this one's a polynomial, and the highest degree here is 2, or the highest exponent here is 2, so the degree is 2. Here we can rewrite b as x to the 1/3 minus 5. We can't have fractions, so this one's not a polynomial. And here, we're dividing by an x that's just x to the negative 1, and that one can't be a polynomial either. Okay, now I want to move on to how degrees affect the graph. So first we have to determine what even or odd degrees are. And so an even degree is a degree that is even. So your highest exponent, or your largest exponent, is going to be even here. And for odd, those degrees are going to be, or the highest exponent is going to be odd. So for an even function, or an even polynomial, let's go ahead and use this black marker, the degrees affect the end, the way the polynomial starts and ends. So I went ahead and paused the video and typed up what I just said. And so an even polynomial, I'm just going to go ahead and graph this f of x right here. It's going to look something along the lines of this. An even polynomial is always going to have the ending lines going up on both sides. So even, your lines for your graph should be pointing up like this, kind of like a parabola. Now, suppose that our leading coefficient was negative. So we had a negative right here. Well, that's going to change the graph completely. So instead of both your arrows pointing up, or your endpoints pointing up, your graph is now going to be pointed down. Now, I know that's not accurate with this f of x, but I just wanted to show that your arrows are now pointing down. So if it's negative for an even, arrows are pointing down. If it's positive, they're pointing up. Okay. But now let's look at something odd. And first off, this polynomial just looks odd, right? Because it's not separated by pluses or minuses. It's separated by multiplication. So how do we find a degree of this one? So there's a couple things we can do. First off, write an exponent of 1 to each one of these, because that's technically what they are, right? The degree, which we're going to represent by d, is equal to all your exponents within your parentheses, or outside your parentheses, added up. Okay, so that's just going to be 1 plus 1 plus 1, which is equal to 3. Now, this one is just an example. Suppose this happened to be of degree 3. then it'd be 1 plus 1 plus 1 plus 3, and so your final degree would be 5. But anyways, that's not what our problem's saying, so just wanted to throw that one out there. So our degree here is 3. Now, an odd function, what it's going to look like, it's going to have that S shape to it. So this isn't accurate to our red f of x, but it's going to have some sort of shape like this. So essentially what we're going to be getting out of this is that a positive leading coefficient up front will have the lines going to some s. So it'll start by going down and by going up. Now if it's negative, it'll be the opposite, just kind of like our evens. So now it's going to be flipped. So we'll be decreasing at the beginning, decreasing at the end. So that's what it'll look like if it's negative. So definitely some good things to have written down for later on. Okay. So let's go ahead and find the zeros of this polynomial. Now, what I want to do with this problem before we just jump into it is find the best way to graph it. And now we won't graph this one, but by finding the zeros, or your x-intercepts, we will be able to graph it more efficiently. So here, the zeros are when f of x, or your y, is equal to 0. So here, if this x is equal to 0, f of x is going to equal 0 twice. Now we're going to talk about multiplicity here in a second, but I'm writing 2 zeros down because it has an exponent of 2. Okay, let's move on to this guy right here. We just got done with him, but now when is this section, this green section, going to equal 0? Well, that's just when x is equal to positive 2. Okay, and that's it, because we don't have an exponent to that parentheses. But now let's look at this blue section. Here, that will be negative 5 to make that whole thing 0. But since it's to the third power, let's just write negative 5 3 times. Okay, and we'll go over that more here in a second. So what is the degree of this polynomial? Now, we could multiply everything out and find our degree that way, but I find it much easier to just add all your exponents outside your parentheses. So here, you have 2 plus 1 plus 3. So degree is equal to, so degree is equal to 6. And that's even, right? So we're going to have something that looks like a parabola. Okay, multiplicity. How many times 0 happens? So up here are zeros. And so here, since we had 2 zeros, because our exponent was 2, our multiplicity for 0 is 2. All right, just like this. Oops, forgot T. Okay. Now for the green one, 2, I'm just going to abbreviate this to m, save some time, is 1. Now for negative 5, that's just going to be multiplicity 3. So that's to the third exponent. Okay, so that's what multiplicity means. All right, so now let's talk about multiplicity and how it affects the way the graph looks. So here, r is a 0 of our polynomial. And so let's look at our function from before. And here, I'm going to write down our r's, or our zeros. We had negative 5, multiplicity 3. And then we had 0 with multiplicity 2. And then 2 with multiplicity 1. Okay, so if your multiplicity is even, it touches the x-axis. So kind of like a parabola. Remember, if you just graph a parabola, and here's your line right here, it just kind of touches the origin. And so let's look at an example of our function as an even multiplicity. So here 0 had a multiplicity of 2, which was even. And notice how it just touches. Doesn't go through. Now if it's odd, it does the opposite. It crosses through the x-axis at your 0. So when r was equal to -5, notice how it crosses through there, almost like a S. So it should look something like that. Now if it's m just equal to 1, it just has a straight line going through it, but it still crosses. So there are 3 ways for your zeros with different multiplicities to affect the way the graph looks. Odd has like that little S shape going through it. Even touches it. M is equal to 1 has a straight line going through it. Okay, so just as a review, anything with an even power is a parabola, touches it. And then anything with that odd power is an S shape, and it will cross. So here for this one, what is our degree, and what are the multiplicities? So here, our degree, this is going to be 1 plus 1 plus 2. So the degree is equal to 4. So it's even for our ending values. It looks something like this. And then our zeros, so let's call them r's, are 1 with multiplicity 1. And then -2 with multiplicity 1. And then 2 with multiplicity 2. So let's go ahead and graph these. So first, I'd start off from the left with the lowest 0. So that's a multiplicity 1, so it's just going to go through the point -2. Okay, now we've crossed 2. We got to start making our way towards our next lowest 0, which is 1. And so since our multiplicity there is 1, it's going to go through it. But now our next one, so r is equal to 2, with multiplicity 2, so that means it's going to be like a parabola. It's going to shoot back up just like that. And then we finish our line. So that's what that one's going to look like. Not exact, obviously, but now let's go ahead and look at a trickier example and try to graph it more accurately with a couple of steps. So when graphing a polynomial, I want you guys to follow these steps, and it'll make it as accurate as possible. So the first thing we do is find the degree. So our degree is adding up all of our exponents. This would be 2 plus 3, 1, and 1. Now a lot of you guys might be wondering, why aren't we adding this 2 right here? And so for right now, we're not going to worry about adding that 2. All we're going to be worried about, like I said earlier, is adding all of our exponents outside parentheses. So we would be 2 plus 3 plus 1 plus 1, which is just equal to 7. And so this is going to be odd. And so we're going to have some function that looks like this. All right, so what's our x and y intercepts of this graph? So the x-intercepts are just those zeros we were finding earlier. So let's go ahead and do that. So here, in order to make f of x equal to 0, we just have to have x, or r0, equal to 0. And now I'm going to do the same thing I did before with the multiplicity and write 0 down twice since we have an exponent of 2. Okay, let's look at this one. X now has to be 4 in order for that bit to be 0. I'm going to write 4 down 3 times just because it's an exponent of 3. Here, x has to be -3. And I'm just going to write that one down once. But now this one's a little trickier. This one we're going to be looking at later on. Just want to give you guys an introduction into it. Here, how do we solve for x squared to, or this bit right here, to be 0? So, now hopefully this is going to look familiar here in a second. It's going to look like the imaginary numbers. Okay, so here it's going to be plus I and then minus I. Okay, so anyways, we're not going to worry about this right now. This is just going to be late. We're going to be talking about complex numbers later on. I just wanted to show you guys that we will be working with them later. Okay, so now we have to find this y-intercept. Now to find the y-intercept, we just put x is equal to 0 in there and solve for f of x. Well, if we set x equal to 0, we plug in 0 into here, 0 times anything is just going to be 0. So in this instance, our y-intercept, which I'll just label as y, is equal to 0. So you know it's going to cross the y-axis at 0. All right, so we found our x and y-intercepts and their multiplicities, right? Now let's figure out where the graph crosses or touches the x-axis. So let's go ahead and start off with our smallest one, -3. So -3 has a multiplicity of 1, which means it will cross the x-axis. Okay, now let's go to our second smallest, which is 0. And so we have 0 with multiplicity 2, but that one's just going to touch since it's an even multiplicity, and so it's going to look like a parabola. Now we go to our largest one, 4. And 4 has a multiplicity of 3, which is odd, so it's going to cross with that S shape in it. Oops. Okay, so we figured out all of our x's and how our multiplicity is going to affect the graph. Now, let's go ahead and graph this guy. So I'm going to pause the video. So I took out the graphing calculator and put in our function into y equals. And now you guys should be doing this with me also, just so that way you guys get better at this. And I've adjusted the window a lot. I've played with the zoom fit, but I found that it didn't really fit the graph that I wanted to have, I guess. And so I just ended up messing around with my own window and got this as my function. So remember, we got -4 as an odd, so it goes through. 0 was even, so it touches. I'm sorry, -4 was, wait, so let me make sure I'm saying this right. Okay, so sorry. So anyways, -3 had a multiplicity of 1, so it just went straight through. 0 had a multiplicity of 2, so it kind of bounces off like this. And 4 had a multiplicity of 3, and you see how it snakes up like that? So now we've kind of shown everything graphically. Okay, so what's the next thing we need to do? We need to find the local max and min of this graph to make sure we can graph it more accurately. Okay, so second trace. Let's go ahead and start at the minimum. Now you guys have done this, so I'm going to go ahead and pause the video and come with the solutions. When I unpause it, you guys should be doing this on your own for extra practice. All right, so here's our maximum and minimum. One thing I failed to mention before I did this is that you guys should be able to do everything before D and graph it with a quick sketch, kind of like I did earlier. I will be asking you questions like that to graph it without using a graphing calculator, but then there are times where I wanted to verify or have you guys come up with a clear example or a clear graph using a graphing calculator. So here's our maxes and mins, and now we can determine are the domain and range given these maxes and mins. Now if we look at our graphing calculator, our domain is what x can legally be, and so this guy's just going to stretch out on both sides of our, it goes from negative infinity to infinity for all of our x values. So our domain is just all reals. Okay, but our range is a little limited because the lowest point is going to be our min here, but it can be anything greater than that. So our range is going to be, now what's our lowest minimum? Here, it's our lowest value, it's the local min. This would be negative. And that's just going to go up to positive infinity. Okay, so that's our domain and range. All right, last thing. Where is it increasing slash decreasing? And so with this, we're going to use interval notation. But it's going to be decreasing in all of these values right here. So if we look at our max, our min values, our local max, local mins, it's going to be decreasing to our first local min, which is this value. And so it is decreasing from an interval negative infinity to, I'm just going to leave out the decimal to save time. Now remember, it's not a closed bracket because at the minimum point, it's level and it's neither increasing or decreasing. So draw this out. Here it is decreasing, but at that vertex right here, it's flat. And so it's neither increasing or decreasing. Okay. Now, after this, it is increasing from that point all the way to our local max 0, 0. So it is increasing from, oh, by the way, hold up. I actually messed this up because this is a y value, right? And we're looking for x values in these intervals. So instead, we're going to use this x value right here. So that's my apologies. So let's go ahead and look at that value again. Negative 2.48. Okay. Now, looking at our x values, increasing from negative 2.48. And increased all the way up to 0. All right. Now we're looking at this other blue line where it's decreasing. And so there, it'll be decreasing from 0 to whatever our next local minimum was. And that would be this guy right here, 2.315. Okay. Now if we look at our graph, we're not quite done yet because it's increasing for everything up to here. And so we can write that 2.315, comma, positive infinity. Okay, so those are all the steps to graph a polynomial. So what you guys learned in today's video is how to graph polynomials given specific facts about them, like their degree, their multiplicity of different zeros, max and mins. Anyways, you guys have all these different techniques. You guys should be able to graph it by hand, not very accurately, but still be able to give a rough sketch and be able to come up with an accurate sketch using your graphing calculators. Anyways, sorry this video was so long, but thank you guys for watching it, and I hope this video was beneficial. See you next class.